Welcome to the Not Old Better Show, Smithsonian Associates interview series on radio and podcast. The show covering all things health, wellness, culture, and more. The show for all of us who aren't old, we're better. Each week, we'll interview superstars, experts, and ordinary people doing extraordinary things, all related to this wonderful experience of getting better, not older. Now, here's your host, the award-winning Paul Vogelzang.
Thank you, and welcome to the Smithsonian Associates interview series on the Not Old Better Show. I'm Paul Vogelzang, and today's conversation is as big as it gets. We're talking about the future of life, not just on Earth, but beyond it. Our guest today is Smithsonian Associate Dr. Caleb Scharf, NASA astrobiologist, acclaimed author, and one of the boldest thinkers about the place of life in the universe. In his new book, by Dr. Scharf, The Giant Leap, Dr. Scharf makes a provocative case that our expansion into space may not just be a technological milestone, it might be the next phase of evolution itself. Smithsonian Associate Dr. Caleb Scharf calls this moment a disruption in the story of life, as profound as when creatures first crawled out of the sea. Dr. Scharf has spent his career studying black holes, exoplanets, and the fingerprints of life across the cosmos. Dr. Scharf is also a storyteller, you will enjoy that today, who blends science with wonder and reminds us that the night sky isn't just something to look at, it's something we're becoming part of. If you've ever stared up at the stars and asked, where are we going next? This episode is for you. Settle in. I've enjoyed putting the music together. I think this will take you back a bit, but the questions we're asking today are all about what's ahead. This is the Not Old Better Show Smithsonian Associates interview series. Please join me in welcoming Dr. Caleb Scharf. Dr. Caleb Scharf, Smithsonian Associate, welcome to the program.
Thanks so much for having me on.
Happy holidays to you, sir. It's so nice of you to join us. It's such a busy time of year. You've got this wonderful new book, and we're going to be talking about it, The Giant Leap, as well as your upcoming Smithsonian Associates presentation. But I just wanted to start. I read about you, and I read that you've written that space. It's really interesting. You say that space isn't just humanity's next destination; it's life's next evolutionary leap. And I wonder, for those of us that have watched the moon landing in black and white TV, how should we think about rockets today? Not just taking us somewhere, but perhaps changing what we are in this evolutionary kind of manner.
Yeah, so this is part of the thesis of the book, which is to take a step back and ask what the bigger implications are and have been of sort of exiting our place of origin, of learning how to get into space, learning to go to other places in our solar system. And, much of this was already underway during the time of the moon landings and the Apollo era. But I would say there are two things going on here that are about changing not just us, but changing all of life on Earth. And the first is that through space, we've become a species able to sort of look back at ourselves in a way that's completely unprecedented. In the history of life as it's been on the Earth for 4 billion years, we now have satellites that image the planet again and again. We can examine every piece of the surface area of the planet, and it's that information drives our actions. It enables us to make choices in agriculture, in planning our human world, but also in understanding the natural world. It's transformed our communications. It's transformed our ability to predict things like the weather. It's transformed our ability to navigate, to locate not just ourselves, but other species on the planet. We can put a tag on a bird and track its migration around the world. And the thing about us in particular, although it's true of any species on Earth, is that if our actions change, they inevitably alter the environment of all other life on the planet. So one piece of this is that our scrutiny of the world and ourselves and the changes brought upon our actions by being in space are profoundly altering how we behave and therefore how all of life on Earth finds itself. Beyond that, I think there's this much bigger picture view of the changes induced on us and on life on Earth, which is really just, what happens when life breaks free of its point of origin? This hasn't happened before. We've been essentially constrained to this one world. And now, through us, life can access other parts of the universe out into the solar system. We're just in the beginnings of that. And so what the end product of that is still very unclear, but we know that it's going to change things. Anytime life on Earth finds itself in a new environment, hops over a mountain range and ends up in some new set of conditions, it undergoes changes. Life scattered across a place like the Galapagos Islands. You took one or two species and suddenly they diversified into a multitude of different species. And so I think that is part of the bigger picture of what's happening and going to happen. So we've moved on from just setting foot on the moon.
Yeah.
Many, many things have happened, and it's changing life in all sorts of interesting ways.
Yeah, you have another interesting way of putting things. Do you compare space exploration to Darwin's voyage on the Beagle as both being redefining how we see life itself? And I wonder, I know you've had a role with the James Webb Space Telescope, and I wonder if Darwin had access to the James Webb Space Telescope, what do you think he would have been most fascinated by, knowing of this redefining as we see life itself?
It's a wonderful question to imagine Darwin being exposed to this. And I think the thing that I would find most interesting, and I think could be the biggest reaction from someone like Darwin, would be to be shown objects that existed in the distant past, to be shown the age of the universe, to be shown things that are so far away that their light set out towards us before modern humans existed, and perhaps even before the dinosaurs existed. To let Darwin see in the pictures of something like the James Webb Space Telescope, the very first stars and galaxies to exist in the universe 13 billion years ago. I don't know what his reaction would really be, but he was such an incredibly curious person, such an analytic person, that I think his vision of the origin of species, the evolution of life on Earth, would be so vastly expanded by seeing that even that is just a microcosm in this much greater cosmos. And that's really what, something like the James Webb Space Telescope or the Hubble telescope or other space telescopes and telescopes here on Earth have revealed to us since Darwin's time, is the age and scope and evolution of the entire universe, not just the little crumbs of matter walking around on the surface of the Earth.
Well, let's talk for a moment about technology and how we are so entangled. And you write about this, and you say that this planetary transition is one that's taking place with us and technology very much enmeshed. And I wonder, does that go so far as to suggest that we might be becoming a new life form here? Are we some kind of biological, technological hybrid? And what does that mean for those of us who are aging and we want to relate to one another and still remember what's going on around us?
Yeah, this is a big question.
Yeah.
And I would argue a couple of things. I'd say, first of all, we're already a hybrid life form. And, we perhaps don't realize that, but I think we have been since the first time some human wrote down a symbolic representation of knowledge, in whatever alphabet or pictorial system they devised to represent information. That is an augmentation of our biology that very few other species, if any, have to the degree that we do. We keep information with us. We express information. We exchange information in ways that don't require our immediate presence. They're sort of in our symbolic writings, but they're in our machines and the structures we produce. And of course, this has been going on a long time, and we've augmented ourselves with technology that helps keep us warm and fed, and and provides light at night, and so on. So I would say part of this is we're already quite a curiosity in the history of life on Earth as a sort of hybridized form. Where space exploration comes into this is that I think it already is, and it will vastly accelerate this process. It will throw fuel on the fire of human technology hybridization, because it's very clear that humans and most other life on Earth simply doesn't survive without technology when we go beyond the confines of the Earth. And that's not too surprising, right? We evolved out of these conditions, and so those are the conditions that we require. So technology becomes an integral part of existence in a way that's even more extreme than it is currently on the Earth. So that's going to be really, really interesting. And it's to do with robotics, the fact that we might need to augment our physical actions in the world through robotics even more when we're in space, whether we're on Mars or exploring asteroids or something like that. But also the ways we transmit information and communicate with each other, and store information. And I think how all of this relates to, the nature of aging, the
Yes.
nature of communication, the nature of, how we do things in the world. I think we're already seeing elements of that. I mean, I always think about how, for example, and this again is a very sort of Earth-centric picture of things in our history. Isn't it extraordinary that someone like Shakespeare, who died 4 centuries ago, still expresses himself in his literature and his art, and we can read that, we can absorb that, we can have a type of conversation with Shakespeare, even though we never encounter him physically in our lives. And the same is true for all of us. Right? We have this capacity, and especially perhaps as we age, to lay down our life experiences, to have a legacy in the information we leave behind, whether it's a story we tell our grandkids or whether it's something we write down. And the capacity to remember things is also changed dramatically with technology. I mean, I don't know about you, but I know for me, I recall far fewer facts than I used to.
Right.
And the reason is I don't need to so much. I can pick up my phone and what's the name of that place that I once remembered I saw in, Spain 20 years ago? Well, I can look it up,
Yeah.
right? I can have the answer at my fingertips. And so that's, I think, very, very interesting, especially as we all get older. We know there are cognitive challenges sometimes to getting older. Well, we have a support mechanism in this technology that no other generation really had before, that can sort of augment our memory. And I think we've all had the experience, we temporarily can't quite remember something, but the moment we see it written down or we retrieve it with Google, it all falls back into place, which is wonderful. I think that's a transformative thing. And of course, communication as well, and space exploration amplifies the need for forms of communication that are sort of coherent across time. Uh, you know, right now we live in an era of instant communication.
Yeah.
That wasn't true a century ago or 2 centuries ago. And it may not be true in the future if we spread across the solar system, because it takes time for signals to get around. And so we may have to get used to, again, to sort of delayed communication, be more careful and considered in what we send out, because we won't get an answer for 40 minutes or an hour.
All fascinating. You mentioned Mars, Dr. Scharf, and I want to talk for just a moment about that, because the Earth has always been home in all its beauty and frailty, perhaps. But you also say that that the Earth may no longer be the best cradle for life. And so I wonder, for those of us in our 60s and 70s who ask the question, why should I care if humans live on Mars. I'll never go there. What does that mean to you? And how do we think about Mars and kind of spreading out throughout the universe as being this leap, this giant leap?
I think it's a fair question, right? And perhaps every generation as they get older asks this, whereas maybe I don't care so much anymore because it won't impact me directly. I think, uh, you know, the question of why should I care if humans end up settling on Mars or visiting Mars for extended periods, partly it's a question of curiosity. It would be wonderful if it happens within any of our lifetimes. But it's also a sense of pride in what humans are. I mean, humans are awful in all sorts of ways, but we're also amazing and wonderful in so many other ways.
Yeah.
And one thinks about not just a legacy, but just the enterprise of being human, the adventure of being human. And I personally would want to feel that will carry on and that this spread from the Earth, this escape of life from its point of origin, which has not happened before in 4 billion years. What an exciting and extraordinary moment to be alive. Wouldn't we want to see what that means for our families, our descendants, but also just for this human adventure, this human enterprise, and for the nature of all life on Earth. All life on Earth goes along with us inevitably, whether it's in microbes or food stuff or whatever. We're not going to be doing this alone. So for me, it feels very positive to think that there's something potentially new happening for our species and for all species on the Earth. And that when new things happen, the opportunity to do better arises. If you don't do anything new, the opportunity to do better tends to stagnate. And I think we all know that we could do better as a species, and maybe Mars and space is a way to do that.
You are, of course, listening to the Not Old Better Show Smithsonian Associates interview series. If you're just joining us, we are speaking with NASA astrobiologist and author Dr. Caleb Scharf, who's a Smithsonian Associate and whose work asks us to think differently, not only about where we are in the universe, but what we might become. From the early days of stargazing in rural England to holding images of distant galaxies in his hands, Dr. Caleb Scharf brings science down to earth and sometimes far beyond it. Let's return to our conversation now and explore why the future of life might mean letting go of old boundaries and even old planets. Welcome back, Smithsonian Associate, Dr. Caleb Scharf. Hi, this is Paul. Before we jump back into today's show, I want to take a moment to recognize a truly special milestone, Smithsonian Associates' 60th anniversary. Since 1965, Smithsonian Associates, the largest museum-based education program in the world, has been inspiring lifelong learners with unforgettable experiences, connecting audiences with the Smithsonian's museums, research, and experts in new and exciting ways. This year, the celebration is for you, with a full year of special programming both online and in person, from behind-the-scenes looks at Smithsonian collections to conversations with astronauts, historians, filmmakers, and curators. There's something for everyone. Smithsonian Associates has created something extraordinary. I'm proud to partner with Smithsonian Associates to share their incredible programs with the Not Old Better Show audience. Thanks for being part of this journey. Here's to 60 years of curiosity, learning, and discovery. Smithsonian Associate Dr. Caleb Scharf is our guest today. Dr. Scharf's research interests include the study of exoplanets, exomoons, and the nature of environments suitable for life. In 2022, Dr. Scharf received the Carl Sagan Medal from the Division for Planetary Sciences of the American Astronomical Society. Dr. Scharf will be at Smithsonian Associates coming up. He's joined us today talking about his wonderful new book, The Giant Leap: Why Space is the Next Frontier in the Evolution of Life. It is a fantastic book. Thank you, Dr. Scharf, for sharing it with me. But so many others have high praise, including a previous guest of the program, Lord Martin Rees, a Smithsonian Associate, who says, Dr. Scharf's fascinating book presents a panorama of the solar system, describing what's already been discovered and speculating about the greening of our cosmic habitat, planets, moons, and asteroids. It's enlivened by Darwinian cameos, offering new insight, even to those familiar with the subject, but keeps a welcome focus on explorations feasible in the human era, steering clear of flaky science fictional territory. Wonderful praise for your book, Dr. Scharf. And of course, we so appreciate you being with us. And I want to talk about some of your experience looking deep into space, because you've really seen some of the very earliest galaxies in your work through space telescopes, and you've kind of held these wonderful images in your hand, including black holes. And I wonder what has been the most awe-inspiring moment of your career up to now, because I think there's something that the way you describe this work, it's just inspiring, but something that made you genuinely gasp.
Well, if I think about it, I would say it actually is something connected to, but not directly, my research in astrophysics and so on. But it was the very first time that I went to use a large professional telescope at an observatory as part of my research. And it was my first trip to the Southern Hemisphere as well. And large professional observatories tend to be in very remote places because you want to get away from the polluting light of human civilization. And you need an environment that's very stable and has good weather and so on. And I just remember the very first night arriving at this rather remote astronomical observatory and stepping outside. So not sitting in the building, the computer screen, but stepping outside. And my jaw hit the ground because, first of all, it was the darkest night I'd ever experienced, which meant that the stars were the brightest I'd ever seen them to my human eye. And I was in the Southern Hemisphere, which I had never experienced before. And the night sky is, of course, different because you're looking in a different direction. And as I looked around, I realized two of the things I was looking at. One was were the Magellanic Clouds, which are the nearest satellite galaxies to our own, and they're these fuzzy smears on the sky. They have size; you can see them. They're right there. And then the second thing that I realized was that I was looking at the Alpha Centauri star system with my naked eye, the closest star system to us, merely 4 light years away, and that felt really profound. It felt, because I knew Alpha Centauri, okay, that's the closest star system to us. And there it was, bright in the sky. And it's a very bright pair of stars in the sky. And that was a moment of awe until my colleagues dragged me back in to actually do work.
It all comes crashing down maybe at that point. You once joked, and I love this about you. You have a very nice sense of humor. And you say that possible delays in the James Webb Space Telescope gave us the time to develop 8K TVs, which allow us to truly see the images in the galaxies. And do you think the beauty of these cosmic pictures is really part of their scientific purpose to really kind of help us feel what we're discovering and not just know it?
Yeah, that's a really interesting question. And I think, so many of the images that we get from telescopes like the James Webb Telescope or the Hubble Telescope, we do construct them in such a way that they're aesthetically pleasing, but we also construct them in a way that they're informative. So the colors we assign to things help us as scientists know what we're seeing, whether we're seeing hydrogen gas or some other elements, and whether it's hot or it's cold or what type of star we're looking at and so on. And I think in science is such an interesting pursuit, and the beauty of these images is important because it's part of gaining really an intuition and an intimacy with these phenomena. So science is in part methodology, right? A set of rules. This is how you do science. You gather data, you analyze the data, you try to make unbiased statements about what the data is telling you. And there is a scientific method. But on top of the scientific method, there has to be a very human intuition and instinct for what you're seeing, because that's where you make discoveries. You find yourself surprised by something. I look at a beautiful picture of a nebula taken by a space telescope, and I look at it, I think, oh, that's aesthetically so wonderful. But then I think it leads you to a deeper feel for what is there, which is something hard to quantify in numbers. But our brains are very good at that. Our brains are marvelous pattern recognition devices. So I think the other role, the role of that beauty is to create familiarity, to create recognition of sort of an instinctual feel for what we're looking at, because in that is where you get discoveries. That's where you ask questions. You go, well, why does it look like that? Or what's going on? Or this looks strange compared to other things that I've seen. So absolutely, I think, there's a hard-nosed scientific reason for beautiful cosmic images, but it's also, on the other side of it, it's the human connection. This is our universe. We're part of this. We should appreciate it.
It's beautiful. Well, we hear a lot in the media these days, whether it's from NASA or from Elon Musk or others, about this idea of colonizing Mars or terraforming planets, maybe more broadly. You've said that the solar system could easily produce and support 50 trillion humans living in 6,000 Earth-size biospheres. I just thought that was fascinating. Where do we go if we're not going to kind of Earth 2.0? What are these biospheres?
Yeah, it's nice provocation, isn't it? 50,
yes, absolutely.
Can you imagine?
yeah.
But it's actually, it has a real basis. So, part of what I came to the conclusion about as I wrote the book and thought more about all these questions of what might the future hold is that, planets are kind of a pain in the neck. Somewhere like Mars, it's superficially like Earth, but in every other way, it's very, very different. It's very alien. It's very difficult for us to exist there. We would require technology to support us. And there are certain things that we'll never be able to alter about a world like Mars, which I think imply that it may not be the best place for us to sort of put ourselves. And, we might terraform Mars, we might try to change its natural environment to make it more suited to us and so on and so on. But one thing we can never change, for example, is the surface gravity on Mars. So on Mars, you will always weigh a third of what you weigh on the Earth. Now, we have no idea what that does to human physiology in the long term. We really don't know what it implies for even generations of humans who are born and die on Mars. We just don't know. And it's just one aspect of how a planet is like Mars. It may not be the best place to go. It also takes a lot of energy to get on and off the surface of a planet, right? You need rockets and you need to land and safely and to launch safely and so on and so on. Other options exist in the solar system, and our planet-centric view of things may be due for some change because it's the viewpoint of a planet-bound species, a species that has not yet left its point of origin. However, we have left our point of origin. So I think we need to look at what the solar system is slightly differently. And one possible option is to create habitats that are perfectly tuned to the conditions that produced us on Earth. So they're tuned to create artificial gravity by spinning our habitats to create an artificial force that mimics Earth's gravity. We can produce exactly the atmosphere we want. We can populate it with terrestrial organisms to help maintain our immune systems and all the things that we've evolved in concert with. And if you start asking, what does that look like? Well, the obvious way to build your habitats is to harvest or utilize the smaller objects in our solar system, the asteroids, of which there are millions, perhaps billions. And this figure of 50 trillion humans and 6,000 Earth-sized biospheres actually comes from when you take a look at the elemental composition of life on Earth and the Earth's biosphere, how much carbon, how much oxygen, how much nitrogen, how much phosphorus, and so on, and then ask how much of that stuff is readily available out in the rest of the solar system, not on planets, which are an absolute pain to deal with, to get on and off, but asteroids, which are in principle much easier to access and to manipulate. It turns out that the amount of stuff out there could easily allow you to grow or build something like 6,000 Earth-sized biospheres. And if each biosphere sustains the same number of humans as the Earth currently sustains, with a little fudging of the numbers, you end up with about 50 trillion humans without touching another planet. That is all just harvesting the sort of detritus that orbits around the sun. It's staggering. It seems utterly fantastical, but it is a boundary condition. It is an endpoint, a potential endpoint for life like us that breaks free of its planetary origins. That's what we're looking at, that kind of extraordinary scale in terms of the number of potential individuals and the amount of resources available in our solar system. It's a very, very different landscape than anything we've encountered before.
How are we doing maintaining the solar system? Because you write that there are somewhere near 45,000 human-made objects in Earth's orbit, and perhaps another 140 million pieces of space junk. Are we doing the solar system a disservice here? Are we just going to treat the solar system the way we have Earth? And what do we lose if we turn this into this giant kind of junk heap?
Yeah, I mean, there are a couple of pieces to this, I think. So the near-Earth environment that we've been busy populating with satellites and junk is one thing. The broader solar system is something else. The rest of the solar system is so vast, so enormous compared to anything that life on Earth has encountered before. I think it's a very long time coming. It will be a very long time before we impact the rest of the solar system to any noticeable extent. However, our immediate earthly environs are a different story. And so already the amount of junk orbiting the Earth, this is stuff from spent rocket stages, exploded pieces of satellites, just chips of paint off of spacecraft and so on orbiting the Earth, is problematic. It is a concern for putting up new satellites. You have to be careful which orbits you place them into, because you don't want to get hit by any of this material, which is moving at tens of thousands of miles an hour. So if it hits you, it's very destructive. So there is a potential problem that we are making life really difficult for ourselves. All the benefits we get from satellites, satellite data, are balanced against, it's maybe becoming increasingly perilous to put anything in orbit around the Earth. So that is definitely pollution and a problem. There's even pollution of stuff re-entering the upper atmosphere of the Earth. It has been noted and measured that there is a noticeable change in the upper atmosphere chemistry because of re-entering satellites. We don't yet know what the ramifications of that are. But perhaps most interestingly, and interesting is perhaps the wrong word, but sort of depressingly, one of the things that populating the orbital space around the Earth with satellites does is it impedes astronomy. It impedes our view of the universe. Satellites reflect sunlight. Many of us may have seen a satellite passing overhead on a sort of summer's evening where the sun has gone down, but you see this thing tracking across the sky, and often it's a satellite reflecting sunlight. Now we have thousands and thousands of satellites in orbit. For astronomy, that's a problem. Astronomy relies on unpolluted images of the universe because we're measuring the brightness of things to high precision and accuracy. We're evaluating the contents of the universe around us. And a satellite zipping through your field of view is like shining a flashlight down your telescope. It ruins everything. So, it's rather perverse that our move out from the Earth into the universe may also be obscuring our view of the universe, the very view that we so desperately want to have and to understand. And it's also, something that all humans, I think, have a right to. It's an unimpeded view of the night sky and the universe beyond. So, yeah, there's some big questions. What do we do? Do we clean up our act a bit? Do we have to wait for some sort of disaster where satellites crash catastrophically into each other, disrupt global navigation? Who knows? It's an ongoing question that we have to answer.
Dr. Scharf, if you had the opportunity to send one message into deep space that would be found 10,000 years from now, not scientific data, but just a sentence perhaps that captures what it meant to be human in this era, what would you write?
The humor part of me would say dazed and confused.
Good. I like that.
The slightly more poetic side of me might want to say something like, we discovered the universe and we hoped we could become part of it.
So wonderful to talk to you. Of course, Smithsonian Associate, Dr. Caleb Scharf, our guest today, author of the wonderful book, The Giant Leap. We'll put links so that our audience can find out more about Dr. Scharf, including his upcoming presentation and his wonderful new book, The Giant Leap, Why Space is the Next Frontier in the Evolution of Life. Dr. Scharf, happy holidays to you and yours. Thank you so much for your time. We'll look forward to seeing you at Smithsonian Associates. And just selfishly, please come back and talk to us again. I know this is constantly changing. Your work is constantly being updated and new things are being discovered by you. And so we'd love to hear more.
I would love to come back and tell you more.
That's our show today. A big thanks to Smithsonian Associate Dr. Caleb Scharf, who will be appearing at Smithsonian Associates coming up. Dr. Scharf has helped us look up and think bigger. His insights into astrobiology, technology, and the evolution of life itself offer a powerful reminder that even now, we're still becoming something new. You can learn more about Dr. Scharf in our show notes today, including his upcoming presentation at Smithsonian Associates. If today's episode sparked questions of wonder, you can find more from Dr. Scharf in his new book, The Giant Leap, and through his work with NASA. To listen to this episode again or to explore our full catalog of past conversations with scientists, artists, and thinkers, visit us online at notold-better.com. You can also follow us on social media. We're on Twitter X at NotOldBetter and Instagram at NotOldBetter. This episode is a production of NOBS Studios. I'm Paul Vogelzang. Thanks for spending time with us today. Let's talk about better. The Not Old Better Show, Smithsonian Associates interview series on radio and podcast. Thanks, everybody. I hope you'll join us again next time. Until then, keep asking the big questions.